I want to start this video off with a little guessing game. Let's say I have two numbers, two mystery numbers. You have no idea what they are. I've got one of the numbers in this hand, and I've got another number in this hand. So there's one number in each hand. You guys have no idea what they are. And let's say I took my two mystery numbers and I multiplied them together. So I'm taking my two numbers and I'm multiplying them together. And I tell you the answer to my problem is 0. So I got my first mystery number over here times my other mystery number, and I'm telling you the answer is 0. My question for you guys is, what does that tell you about the number in my hand? Can you say anything for sure about either of the numbers? And this is a good question to think about. This is something in class I would pause, I would ask you guys for your input. You should try to come up with your own answer before I tell you in just a second. So pause the video if you need a little time, but think about that. It turns out that if you have two numbers that multiply to 0, one of those numbers at least has to be a 0. There's no other way you can multiply and get 0. So either this is a 0 over here, and this is some whatever number you want, or it could be the other way around, where this is some random number times 0, or even they both could be 0. But if we multiply and get 0, at least one of those numbers has to actually be 0. That's what the zero product property says. The only way you can get 0, or you can multiply two numbers and get 0, is if one or more of the numbers is 0. Is if at least one of the numbers is 0. So that's kind of taking it and putting it in words there. That property is actually going to be extremely useful in this section. So I have a couple of problems that I want to practice using our new rule. Now, we're asked to solve for x in each of these problems here. And it might look at first glance like this has nothing to do with what we had on the last slide. But if you look at it here, what's really going on is I have two things being multiplied, and my answer is 0. Picture if each of these parentheses, that parenthesis was in my left hand, that parenthesis was in my right hand. It's two things, this parenthesis and this parenthesis, being multiplied together. So if these things are being multiplied and I get 0, either this parenthesis has to be a 0, or that parenthesis has to be a 0. That's the only way you multiply them and get a 0 for your answer. So you have to ask yourself, what number could x be to make this parenthesis a 0? Some people will say at first, well, 0. But if you plug in a 0 here, you get 0 plus 4. This parenthesis is a 4. That's not going to help us get a 0. What we actually want for this parenthesis is negative 4. Because negative 4 plus 4 is 0. Then I'm going to get 0 times, I don't even really care. I guess it's a negative 10, but who cares? 0 times whatever, that worked out. So one of my answers is x equals negative 4. For the other answer, I have to look and see what number could I plug in for x to make this parenthesis a 0. So what number, when you take away 6, gets you a 0? We're ignoring all the rest of it now, and just looking at that guy and saying, what would make him a 0? And it turns out the answer is a positive 6, because 6 minus 6 is 0. And that is my other answer. These are the only two numbers in the entire world you can plug into this problem and get 0 as a result. So on the second problem here, try this one out for yourselves. Try to find your numbers that will make it work. You want to make the left parenthesis equal to 0, and you want to make the right parenthesis equal to 0. On this one here, for the first parenthesis, x equals 15 will work, because 15 minus 15 is 0. And on the second guy, it'll be negative 4, because negative 4 plus 4 is equal to 0. So it's seeming like these problems really aren't so bad. It's pretty much just looking at it and figuring out what number makes it work. I have two more though. So on this one, again, two parentheses being multiplied, we get 0. Either this parenthesis is 0 or this one is. The first guy, we know the answer is going to be x equals 7. On the second guy though, that's not very easy to see just by looking at it. Not a lot of people at this level can just look at that and be like, well, the answer is blah, blah, blah. So when that happens, you have to do a little mini algebra problem. We wanted this thing to equal 0, right? So that means we can actually say 2x minus 9 equals 0 and figure out what x is. So I'm going to do a quick algebra problem here. I'm going to do thing equals 0 and see what value for x actually makes it work. So I get 2x equals 9. We get x equals 9 over 2, or 4.5 for our other answer. If you think about it, you could have been doing that all along with these. It's not necessary with a parenthesis like this. Like I could have done over here, x minus 7 equals 0, and just solved it for x, and gotten x equals 7. But why do that when you can just see the answer? When it's an uglier parenthesis, you just do a little math problem and you're good. So on this one, both of these pieces here are kind of ugly. I'm just going to do 2 quick math problems. 3x plus 4 equals 0, and I'm going to solve that. My first answer is x equals negative 4/3. And my second guy over here, I do 5x minus 1 equals 0, and solve that. You get x equals 1/5. So, not a bad process. When they're already in little parentheses like that, you just set it equal to 0, and you can solve.